some point.
My pleasure.
Thank you so much, Gene, and good morning, everyone. Very happy to be here. I had to battle the I-5 traffic to get here. I'm pretty excited about that. So, what I'm going to do today is I'm going to basically focus on one main recent result, and that is kind of building least privilege into protocols like OAuth. Okay, and what I'm going to claim is that we're going to give you better least privilege than what you get today, and I'm going to tell you that this better does not come for free, and we're going to characterize what you give up in exchange for better least privilege. So that's kind of going to be the main thing. And then I'll just have one slide that talks about some of the other stuff that we are kind of doing that I could do an entire talk on, but I just want to focus on the OAuth stuff. Okay. So just so that we're on the same page, what is this idea of least privilege? This old thing from 1975, right? Every program, every user of the system should operate using the least set of privileges necessary to complete the job. Right? So very simple idea. But as it turns out, when you try to build real systems, real complicated systems that embody this idea, things get complicated fairly quickly. Okay, so I'm going to try to give you a sense of how this plays out. And so the setting is kind of cloud authorization. Okay, so here we have Alice, and Alice is going to use Zoom to create a calendar event, right? Because you can create a Zoom meeting, and then Zoom will, is going to schedule that meeting inside your calendar. And so Zoom needs a token or a credential of some kind so that Zoom can go and hit the Google backend for calendar and then create an event. Right? Now, obviously, you don't want to give your password to Zoom, so you do this thing called OAuth. Right? And so in OAuth, you may have seen the screen, right? You're going to see this pop up, and it's going to say Zoom wants to access your Google account. Do you agree or not? That is what this cloud authorization is doing. Is that the user is going to grant access to this third-party app, and that access is going to be limited in some sense, okay, without revealing the user's credentials, right? So you don't actually reveal your username and password to Zoom, your Google username and password, but Zoom gets this token, this number that kind of grants it authority, okay? And the way the privilege is kind of mediated here is through this OAuth scope thing, okay? And so that's basically think of it as a set of permissions that Zoom is getting to access your calendar. And if you kind of pay attention, right? I mean, that scope is represented in English to you here. Right? So Zoom is going to view and edit events on all of your calendars. Okay? All events, all calendars, and you have yes or no. And so obviously you will click yes because we want this thing to work out. And so Google Calendar eventually gives a token, which is, again, just think of it as a number, a large, unpredictable number, hopefully, and then Zoom can create the event. Okay, so that is what OAuth is. This is fundamental. This is being used everywhere, right? So Zoom is the example, but your IoT stuff, your business process automation stuff, your ChatGPT stuff, pick your latest thingamajig, and it's going to be using OAuth. Now, so what's the problem, right? This is a security talk, and so where does all of this go on? The primary problem that happens is kind of token leakage and abuse, right? So these tokens are pure capabilities, right? If you have the token, you have the power, and it is very easily lost, right? I mean, this may not come as a surprise, but keeping a database of numbers secure is not exactly a thing that we can do properly, right? I mean, databases of numbers get leaked all the time. And so OAuth tokens are just databases of numbers. And see, these are just few examples of databases of OAuth tokens getting phished or hacked or stolen or whatever. Right? And the thing is, the moment the attacker has the token, they can just do whatever they want with that token. Right? They are no longer bound in any way. Right? That token has power over Google Calendar or whatever resource. They can do whatever they want. This is kind of the one of the main problems we are trying to address here. How do you minimize this abuse when the leakage is going to come? Right? So we're not going to focus on trying to prevent the leakage. That is a very, very hard problem. We're trying to focus on limiting the abuse, right? For when the token is. The other problem is that the tokens are overprivileged. Okay, So again, like in my Zoom example, right? Like what Zoom asked for was the ability to view and edit all of the calendar events. Now, what it needs, if you think about it needs to create new events, right? And then it needs to be able to manipulate events it has created. Right? Why does Zoom need the ability to go and manipulate some event that you created natively in your Google Calendar? Right? I don't use Zoom as an interface to Google Calendar. I will use the interface from Google to manipulate my Google Calendar. So if you think about it, right, it needs a subset of what it is actually asking for. And of course, I put a star there because there are all special cases, but I'm going to keep the kind of the policy somewhat simple. Okay. And so this difference is overprivileged, right? And so you can think, if my model is that the tokens are being stolen here, the overprivilege kind of makes the problem a lot more worse. And so that's kind of the second major problem we are trying to address here. Like, how do we get rid of this? Right, so minimize the abuse, get rid of the overprivilege, reduce the.
But
yes.
aren't you saying basically the problem is granularity?
The problem is granularity, yes.
It's not, it's just that the granularity is typically all or nothing.
Mhm.
And it's not like, oh, I want to create or only manipulate events I create, right?
Right.
But
It's fundamentally a question of granularity.
Okay.
But there are like challenges on achieving the right granularity, and that's kind of come in a couple of slides. Okay, so now, yeah, so why does it, like you might think, right, why doesn't the client just ask for less permission, right? And so we kind of hypothesized three reasons. First one is client developer is lazy / doesn't care, okay? That can happen. Or the client developer can think, like, what if I need some, I need permissions for some unknown thing in the future, I might as well just ask for it all right now, and then, I don't have to ask the user again. And the third one is maybe actually asking for lower privilege isn't actually possible in these. Now, we don't know what the true reason is. It could be any of these three. It could be a combination of these three. The first two are somewhat human processes, right? Like, I mean, the first one, especially like, that is the culture at like Zoom or whatever random company. If they don't care, they don't care. You can't make them do it. Although towards the end, I will come back on I will revisit this point of trying to get them to do the right thing. But for now, we are just going to focus on this third one. Asking for lower privilege isn't actually possible. And so what can we do to make that technically possible? Okay. Okay, so why is it not easy to ask for the right set of permissions? The first reason is that on a very fundamental level, if you think about what's going on here, all of these permission systems, and I mean all of them, are designed with this idea of being server defined, right? So the way it works is that some team in Google who creates Google Calendar, they're going to have a meeting and they're going to say, okay, we have all these APIs and now we need to decide scopes or permissions for them. And so then they come up with some kind of mapping between scopes and APIs. And they say, this is our permission system, and that's it, right? Then the client developer comes and says, okay, I need read and write permissions to calendar events. Please give me a token with this event scope, right? And so what the client developer does is they try to look at what Google is providing in terms of permissions, and they find a match. Right? They try to find a best match for what they're looking. I think is very fundamentally, this best match is not going to be a perfect fit, right? Because again, the team at Google has to design one permission system, and that permission system is the same for millions of clients, all of the clients in the world. They cannot anticipate every way in which their API is going to be used, right? So they have a fixed permission system, but the clients are dynamic. There are many clients in the world, right? And so you will always have that mismatch, and when you always have that mismatch, you will always have overprivilege. There's just simply no way of getting around it, right? Unless you know the guy at Google and you call him, hey buddy, like you need to add this other permission. That's never happened.
So it'll appear to me that in any policy-based system,
yeah,
the identity of the requester is always part of a context in which a particular policy should be given or not. That you're already doing. Why don't you put that as a context inside the policy? If you're if your implementation of calendars through databases and grant access and basically an insert, create, delete, whatever, then solve the problem. It's just a bad design.
So no, so this is a problem of granularity in the sense that Google Calendar cannot anticipate the exact permissions that you need. They will have to make a fixed design decision like, okay, I can create a permission for read access to events and write access to events, but not beyond that. Like, okay, just I can only read events that I have created. They don't have the visibility to creating that. They can only know that someone needs this if Zoom goes and tells them. But Zoom is just one among millions of clients. So you can't go and keep telling Google, hey, keep changing your permission system, right? So here's the example, right? So this is like from the Travis, like Travis is a very popular continuous integration platform. And so the Travis is kind of integrating with GitHub. And so what they're saying is that we need like repo access that gives us read and write access to your GitHub repo. And we need this because GitHub does not provide the read-only scope for private repositories. Okay? So this is exactly the problem. Right? So the GitHub guys, the GitHub developers designed some permission system and they followed whatever process they want. And then now comes along Travis as a new client, and Travis's permission needs are specific. They need like read-only for private repositories. And that permission simply does not exist inside GitHub. And it does not exist for a fundamental reason. They could not have anticipated all the possible ways in which their data is going to be used.
I agree, it's hard to anticipate all possible scenarios, but I feel like a few common sense policies could probably address the needs of many of the clients, right? So in the case of calendar, you do have the permission of, you can create events and only modify your own events. That probably will address the need of many of the clients, right? Are there more subtle policies that other clients might need?
Yes, I will show like policies that like allow you to read objects only once or n times or write objects only n times. You can get like a range of different types of policies. So yeah, certainly. And I'm going to show you some examples. So hopefully did that kind of somewhat answer?
Not particularly, like, I'm still not convinced. I think, to me, this is just a poor design, basically, of the system itself. As compared to, or the permission part of the.
So I'm happy to chat about that with you later, but in the meantime, I would ask you to think about like, if you were at Google and I asked you to design a permission system that is going to match exactly every client's permission needs, if you will solve that problem by the time we finish my talk, we will have an interesting chat.
So, computer scientists are so good at formal languages. I mean, this seems like it should be pretty easy to come up with a composable model where you can describe your permission needs and it will either be approved or denied. I mean, why wouldn't Google do that?
You mean like design a very flexible policy language on?
Yeah, exactly.
Well, that's kind of what we did.
Oh.
We are kind of getting to it. We're getting to it. We're getting to it. It's not a formal guarantee, but I'm getting to that.
The language for specific view-based access control already exists.
Right.
If I can write a query, I can give access to that particular query results. Why is that framework not enough to implement any of these things?
The thing is like, you need to work, like, so there are like all kinds of requirements. Like when you make a language choice, you're essentially telling Google or whoever these guys to commit to using a particular language. And that has certain implications on the semantics of what you're trying to do there. And so we try to not get into that. Like we have a mechanism where you can compile a policy language into something like WASM, and then you get all kinds of flexibility. So just hold that thought and I'll get there. But yeah, very, very, very good points, yes. Okay, the other thing is it's kind of stateless, right? So if that, again, that policy, right? So Zoom can create events or view events it created, like all of your authorization checks right now are kind of stateless, right? It is evaluated in the context of the current request, and your authorization decision is based on information at that moment in time, not information in the past, right? So to enable something like this, you would like abstractly need like this this table, right? That kind of said, okay, for event ID 1, like Zoom did an insert and then did a get, and ID 2 it did an insert. And so you need kind of the state that kind of tells the authorization system that, okay, this is like some log of operations that the app has taken in some other path. Right? That is the only way you can actually execute a policy of that nature. If you don't have the information, you're not going to be able to do it. And so like, what we use on the internet, like OAuth, it does not have this. This is not a thing in protocols like OAuth. And so, yeah, that's kind of the key idea. Like, I mean, how do we minimize the token's privilege to support these kinds of policies, but also keep the system somewhat functional? Okay. So, so in this work, what we have done is we designed this protocol that allows a client app to express the minimum privilege they need. So in this case, I need to create new events and view it, edit events created, and they can express this in a formal way through a program to the API server. And then the API server can basically issue tokens that enforce these kinds of policies that are almost like coming from the client app and are stateful. And to do this, we kind of introduce these two like abstractions, client-defined permission. So in some sense, the client app is participating in this setup here, and they kind of write a statement that expresses what they want. And we do this in WebAssembly for various technical reasons that I'll get into. And then we have a statefulness abstraction that allows this, expression of this new stateful policies. Okay? So that's kind of what we're doing. And the threat model is that, we trust the client app developers and API server. Okay? And this is kind of the status quo in OAuth or any such authorization protocol. You are trusting the client developers and the API. But the threat here is that, as I said, the tokens can be stolen. Phishing attacks, infrastructure misconfigurations. I don't know if anyone here has ever tried to configure an AWS IAM. That's a huge nightmare. So you can create all kinds of issues in your database there, and tokens get lost. So that's kind of the the threat. Okay. And we want to limit the abuse. We want to reduce the power of these tokens to what is required and nothing more, so that naturally you reduce the worst case damage. Is that least privilege is fundamentally about a worst case guarantee.
Good question about your threat model.
Yes.
Why don't we assume that the client app should not be trusted here? Because so when the client app asks for a lot of permissions, I'd be just concerned with that, right? That they might access some events on the calendar that they're not supposed to, right? And least privilege, to me, that means like you don't trust them, you want to give them the minimum amount of privilege, right? So I'm just curious, like why you're assuming client app is trusted.
So that is because in OAuth, that is what you do. Like in some sense, you're already very fundamentally trusting the app to just ask for whatever permissions it needs. And so what we are saying here is like for developers who are like kind of security conscious, they want to reduce their risk profile, so they're going to want to ask for less permissions. So the clients would be like Travis and these kinds of things, where they are like reasonable developers, reasonable people. Now, there are certainly developers that are not trustworthy and should not be trusted, but we don't have any guarantees for these kinds of things.
Because I was thinking about this from the perspective of a user, like the prompt that you showed, right? Do you give Zoom access to all of your calendar events, right? And I don't want to do that, right? And I was hoping that a more fine-grained policy will allow me to just give them minimal permission, more. So then there's this implicit cross assumption that I don't trust them.
Yes, so you can do something like that using this machinery, and we are kind of working on that in a very specific setting. So yes, you're right. Like you can use this machinery to get to that point, but right now what I'm focusing on is the simplest threat model. Okay, cool. So yeah, so maybe good segue, right? So like our core insights as assumption here is that the developer knows the app's minimum privilege. They want to play ball. They want to like work with us. But they don't have the tools to request that minimum. Okay? And so what we're doing here is like technically there's like a mix of server and client side permissions. So what we have today is like these server defined scopes SP. Right? So that's what like these guys at Google are building. What we are introducing is this client defined programs called F policy and F update. Let's ignore the F update for now. Think of F policy as kind of an attenuation. Okay, so SP is like a superset of permissions that the app is getting, and that is what you can ask for at minimum from the service developer. But then as a client developer, you can realize, okay, my requirements are lesser than SP, so I'm going to write a program that attenuates SP to something smaller than SP. That's what F policy is. And so the way this works is that, when an authorization check occurs, Google is going to do what they do, which is like check that your API call is within these coarse-grained scopes. And then they are going to run this client-supplied function, F update, on their authorization server. And this F policy is going to basically do an attenuation check. Okay? It's going to make sure that the request is of less power than a larger one. Okay? And only if that is true, then you call the API function and then you execute this other thing. Get it? Okay? So again, in your mind, like the server has defined a set of permissions, and you have no choice but to work with that. But then now, with this abstraction that we are building, you can, as a client developer, you can write a program that limits your access. Okay, and the way this is architected is that if there is an error in this program, it does not really matter because SP is the upper bound. So if this just says return true, you just default to the security of the system as it is today. So it is robust against errors inside F policy, and so we don't really check that F policy indeed is an attenuation. We could, depending on the language you use to write F policy, but we don't need to right now. The other thing, so SP serves as an upper bound on the token bearer's authority. The second thing is this state mechanism. Okay, so F update, think of that as a program that is evolving a state machine. So think of the state machine as like some kind of JSON that the client developer again defines. Okay, so in the case of Zoom, they are just interested in whether they have accessed certain events or not. So there, that would be a JSON containing event ID and did you actually access that event? And the F update is a program that evolves that simple state machine. So when you access a new event, you add an entry into the JSON. So that's how this works, right? So now your authorization check kind of contains two pieces of information. One is the request as it is today. The second is this state object, okay? That represents the almost like history of your accesses up until this point in time. And both of those ingredients kind of are now serve a security purpose, right? That is the input to the program that does authorization. But then it also produces a new state, right? Because depending on whether the access was allowed or not, your state is going to be updated, right? So for example, say that you create a new event, in your state table, there's going to be a new row saying that Zoom created this event. Okay. Now, all of these programs are written in WebAssembly or WASM. And we do this for several reasons. Primarily, like, WebAssembly is a compilation target, so you can write a bunch of different languages. They all compile to WebAssembly, and then you can lower it to machine code. You can do in-process sandboxing, especially for pure functions. This in-process sandboxing is formally verified. This is very widely deployed. So like Cloudflare and Fastly and Chrome and all these guys, they all kind of run a bunch of untrusted code inside WebAssembly at very large scale. So now going back to the questions that were here about, like, why not just use some, write some, like, use some SQL-like thing or use some language. What we're trying to give here is that it does not really matter what language you use as long as it compiles to WASM. And so that is incredibly important, like, when you try to build a real system, right? I mean, part of the goal in my group is to do this research, but also it has to have some connection to the real world. And I will talk about like my interactions with the Google OAuth team and what their thoughts were, but this was a
Just a quick question, who makes the F policy? Is this the client developer does it, or is?
So like some person, like a security team at Zoom or a security team at Travis would write F policy and F.
But can this task not be shifted to the other side, to the server side itself, to the calendar?
It
Because
could be.
Because
could be.
otherwise you're sort of interfering with the app development itself, right? So it'll be, because the request is what you need and the state, that's all you require, right? So the code for this is dependent on request.
Yes, so in our model, we are trying to create a very generic framework here that would work for any two clients and servers on the internet that speak something like OAuth. If you go to a specific instantiation, especially in the context of Google, they could totally write a bunch of canned F policies that you can select and use it within the.
Yeah, because the concern would be that otherwise the developer may simply say false, false, false for everything.
Or yeah, in this case it would be true, yeah. They could just
Yeah,
say,
you
yeah, just
default
not
to
true,
that.
yes, yes. So that's why like I started by saying our core insight/assumption is that the client developer is willing to participate. Now that totally can be challenged and I welcome the challenges. I was challenged at Google also when I spoke about the stuff, but there are several things we can do to alleviate.
But couldn't you address that by rather than starting from a non-restrictive set of API and then having a policy restricted, why not go the other way? Basically provide an absolutely restricted set of API, maybe a read-only view of very limited events, and then have the developer or the client supply policies that actually will try to extend on that, because that will force them to have to write such a policy.
Yeah, that is an interesting thought. We didn't consider that. I'm not sure what is like, there is the inherent danger of like the client developer writing a program that expands the privileges to the entire set of privileges, which is what you don't want. And it also is like open to errors, right? So if you create an error in F policy and F policy has semantics of expanding privilege, you're just more prone to security issues at that. Whereas here, like even if you have an error in F policy, you're always upper
something
limit.
different though. I think he's saying that you have the agreed upon policy, which is the max, that's fine. But when you start from the lowest, 0 privileges. Then you show me a request, then say, oh, for this request, I need to give you a read permission of this object. So you expand, but you not go beyond the maximum for sure. Otherwise it'll be silly, right? Like it'll be.
So are you suggesting like almost like a development type tool? Like, so when they start out, they have no permission, but then they encounter an error.
Like
and
if you
then
go to
they-
your previous slide, I think that makes it clear, right? So that API belonging to SP, that SP is some kind of a maximum, scope.
So that
Why
SP
not make it a minimum scope?
So SP is like the current, like, so SP is like a set of permissions that the app has asked for from the current set of permissions the server has. And so what you're suggesting is basically make SP like super fine grained. And so is that kind of what you're saying? It's not totally clear. So like SP is a set of permissions designed by the folks at Google.
Right, so why not have them design that to be a very, very limited set of permissions?
Fine grained.
That's super fine grained, okay.
Right,
Okay.
and then F policy would then need to expand on that. Now that puts the burden on the
okay.
client
Okay,
to
got it.
actually
So
engage in this process,
So in
right?
principle, designing an SP that is super fine grained is not possible. Because like, for example, let me just give you an example here. Let's say that Zoom, like, or someone just wants to enforce a policy that Zoom can, when it creates an event, it only is allowed to write a zoom.us URL inside your calendar event and no other content. Okay, that is a permission.
That's it, it's done.
So you can do that in this framework, right?
Yeah.
That's what we are saying.
No, I think
So-
framework is fine. I think what we are saying is, if you look at SP,
Right.
the point I was trying to say was, this is the weirdness of the bad app developers on the Google side, not your side.
Right.
Because they are giving you a very course level granularity for access, which makes no sense.
Right.
They should rather adopt SQL-ish.
Oh, yeah, from
interface
a
for the-
fundamental perspective,
for fine
I
grained
would,
policies.
yes, I would kind of agree with that. But the thing is, again, from a practical perspective, you can't go to Google and tell them like, hey, you need to do this.
They may,
They have a lot of
they may not
code.
agree, that's all.
Yeah, they won't agree. Like, I have tried this, they don't agree.
I think the reason why it shows this pattern is because the user has to validate and accept the permission system. So if you create a lot of course level possible policies, then you have the user to study in detail what is about. This is much easier to use.
Yeah, that's also like, yeah, you can't show them a SQL query. Right? Or then you'd have to like find an English representation of the SQL query. And this is just simpler when you build real software. But I agree with you, yes, it is not great. That's what we're trying to like hit this middle ground between like being realistic, but also trying to solve the problem. Okay, cool. Yeah, I like the good question so far. So let me see where I was. Okay, so yeah, so I was here. So like now the state definitions, right? Like, I mean, again, abstractly, for a framework, you can have any kind of state you can dream of, right? So in the case of Zoom, it's like this table, right? Like your event ID, your object ID, and then like kind of the HTTP method that manipulated the object. You can imagine many definitions of state. And so rather than us imposing a particular one definition or set of definitions, we just allow the client developer to define it for the authorization system. And they represent it as another program that compiles to WebAssembly. Okay. Then there is this other question of like, okay, even if you decide on the client developer defining the state, where do you store it, right? Like, do you store it on the server? Do you store it on the client? On the server, you will need low latency storage to store all of this stuff, right? Because again, your authorization check is on a critical path, and so for any random server on the internet, it is very expensive to get this low latency kind of key value type store for cheap. For some companies it works, for some it does not. Now you could store it on the client side, but then you don't want like anyone being able to manipulate that state data, right? So you need some kind of validation on the state. So again, like there are different instantiations of this idea, and we are trying to solve it generically for two clients and servers. So we went with the client side design. Again, I'll have something more to say about server side. But in our client side design, the actual state table B, is being stored on the client's on Zoom. The server is just storing hashes state. Okay, so technically they're HMAX, but we can just think of them as hashes here. And so you can basically, whenever a call comes in from the server, you can verify, you can check this hash to make sure that the data was not changed. So very, very simple idea. So what do these policies look like, right? So this is like an attenuation policy for Zoom. Okay. And what does it do, right? So like a request comes in, and then you see that it is a post to slash event. So it is creating a new event, and that is okay. So I'm going to allow that. But then you see it is trying to do a post to an existing event. So the E exists in the state object. And then I'm doing this check that kind of is verifying that only the user they have kind of created this event at some point in the past. And so now I'm checking that they are allowed to access it right now. Okay. That's what this piece of code kind of represents. And so this is kind of the code that the client developer at Zoom is going to write. Okay, so like 17 lines of this like Python language in this case. And this is the state updater. So they write these 7 lines, and this is just a fancy way to manipulate a JSON object. Like conceptually in your mind, that's what's happening. A new request is coming in, I'm just updating a JSON structure, and I'm returning the new JSON structure. So 7 lines, very, very simple code.
Okay.
Yes.
Sorry, I know it's a lot of questions,
Yes.
but question though. Since you're focused on Zoom, on this running example of Zoom and Calendar, right, which is great. If you have an external program like Zoom manipulating your calendar, isn't it always possible or often possible for a user to manually change a Zoom scheduled event, right? Insert something like reminders or whatever. So in fact, you have essentially 2 owners, right? And two writers to the event, the Zoom itself and the user who manually changed it. How does that alter? Does that alter your model at all?
So you're saying that a user can manipulate an event that Zoom has created directly. And that is okay. It kind of depends on how they're doing the manipulation. If they go and manipulate it using the native calendar interface, that is fine because that is outside our framework. So our checks don't execute there because you're going through the browser, not through the OAuth.
So like the keyed hash will not be altered?
Sorry?
That, remember you had the
Yeah,
hash?
that will not be updated.
Okay,
So,
okay.
so that state is just unique to the client. The client is Zoom. And when you go and manipulate your calendar yourself through the browser, that's a separate mechanism. You're not going through OAuth there, basically.
Well,
You're logged in.
browser, I manipulate the calendar, say on a Mac, I manipulate it directly in the calendar itself, not the
Right.
browser.
Right.
I guess the answer is the same, right?
Yes, the answer is the same.
Okay.
It doesn't, because the state and all of that is unique to what is called a client ID in OAuth. So all of that is attached to. Okay, so how does this work, right? So like, if we try to implement this for OAuth, like what happens is that some human being in Zoom or wherever, or Travis, they're gonna write these, they're gonna first look at the list of permissions that the server is providing, and they're gonna select from that. That is SP. Then they will write these two programs, F policy and F update, in whatever language, as long as it compiles to WebAssembly. And then they will submit this as a physical human being, right? So there's like a client developer portal, they have a username, password, they log in, and they can submit these programs right there. That's kind of what happens today. The only step that happens today is selecting SP. We just say that, okay, you need to submit these two things in addition to doing that. And then you get this thing called a client ID and a secret. And then the client app developer is going to take this client ID and bake it into their actual application code, and then give the rest of the protocol to them. So when the instance, so your Travis instance or your Zoom, they try to make a request, so they're going to definitely say, okay, here is the API I need to call, here's some request data, here is the state data. It could be empty if it's the first call, could be the state from a previous call, and the token. Then we're just going to do this very simple check, right? Like the token is a valid OAuth token, the API is within the scope, the state hash is valid and current. Then we spin up a WASM module, run that policy, and if it outputs true, then the authorization server goes and calls out to the API, whatever it is. And then finally we update the state. Okay, and then the state, the new state and the response kind of comes back to the client, and the call is complete. So fairly standard set of steps. We just add a few like and conditions to the authorization. So
But the authorization server, that's not Google here.
the authorization server in the Zoom Google case would be Google. Yes.
So Zoom will never get access to the original OAuth token that.
There is a token, yes. There is a plain old OAuth token here. It's just that on the server's end, that token is bound to the policy. Like whenever that token is being used, the authorization server is going to pull the policy bound to it and execute. Okay, so that's kind of the normal case of things. For token revocation, nothing really happens. So when a token is revoked, you create a new token on the server. And internally on the server, the new token is associated with this thing called a client ID. And we map that client ID to the state HMAX. And so the whole thing is basically transparent. So when a new token comes in, just mint a new token on the server, you associate it for a particular client ID, and then you just send it off to the app instance and you're done. Like, we don't have to do anything for revocation and expiration, which is a very important thing because our whole threat model is that tokens are, the database is popped and the tokens are stolen, and you need to revoke and expire. Okay, so the Zoom thing, I've spoken about it a lot. What else can you do? So, in this chat GPT thing, there's like this, like you can like ask it to like interface with your Gmail, and you can ask it to like read through your Gmail, and if you have like a flight confirmation or whatever, try to create an itinerary from that, like a trip plan. If you think about it, right? I mean, if you ask your chat GPT like, hey, just give me my flight details, does it really need to read all of your emails at all points in time? How many ever times they want? wouldn't it be nice if you could kind of enforce this thing where, you tell ChatGPT, hey, read this flight email, it reads it and it's done, right? It reads that particular email object once, you look at your flight details, you take your flight, you're done, right? So in some sense, you get a read once guarantee using the state, if you can have a counter in the state definition. And this is kind of cool because if the token gets stolen at some later point in time, all the past read emails are kind of locked. You cannot use that token to read emails that were already read by ChatGPT. There's a dual of this where you can do a write only once, and this kind of occurs in like these continuous integration platforms, but the logic is the same.
I missed that. So the token doesn't change.
The token does not
Somebody who takes over this email account just reset the state, get around.
They can't reset the state because the state hash is stored on the server. So they can totally rewrite or send whatever state they want. Unless they find a collision in the hash function, they can't actually make it. Okay, so another use case is like, you can have like a dual to the read only, you can do a write once or a read n or write n times. So the read n and write n kind of occurs a lot in like cryptocurrency wallets. And that's one place where some of the infrastructure we built is being used for policies. Yeah, so like you can use keys to sign certain transactions a fixed number of times and stuff like that. Okay, so yeah, so these are the kinds of things that you could build with this framework. And yeah, we kind of evaluated these things. So, what does...
So where do you store the, I didn't get that part. So who stores the counter? So in this example that you got read only email at most once, right? So somebody is storing a counter in this case to sort of, right? So who's doing it? Is the app changing?
The client. The client. But, so like the client app, again, remember, they supply this F update program. Think of that F update as updating a counter. And so, but F update executes on the server, right? So let's say counter is at 0, and then you send a request along with your state, which is counter is equal to 0, then the server is going to execute the program, which is counter plus equal to 1, state is 1, then we hash all of that data and store the hash, send back the result, which is state is equal to 1.
So it's a philosophical question, but I think that the point was that if the least privilege is a responsibility or sort of a desire of the server, it'll appear on our behalf, and not necessarily a desire of a basically client when writing their programs. And I think there's something going on here where the responsibility, the clients have to be, the client programmers have to be really good people at this stage.
Yes.
So I think there's a little bit of is there a solution outside of that assumption?
So
we
in
don't
this
change
work,
the behavior too much.
yes, in this work, this is the assumption. I'm going to talk about ways to get around that assumption, but we're still working on that. It's like, I don't know how to solve that. It is a valid problem. But I think it is very important to solve this problem first before you can move there. Okay, cool. So yeah, I'll, latency. Okay, so end-to-end latency. So in this graph, the X is the number of objects in a single call to the server, and the Y is just end-to-end latency measured from like you start a counter, you send the request, you get back the data, you stop the counter. Okay. And so the orange pieces are like what we add with our entire policy execution, state update, state hash, all of that is in the orange lines. The red line bar is the network latency to transmit that state data from the client to the server. And the blue is just like native OAuth, the baseline. Okay, so if you have like a lot of objects in one request, it's going to obviously increase, but this is not a very common case. Like it's usually you don't like manipulate like hundreds of events at the same time. You're like, it's very like one or two events. So that's like 4.2. So I think that's kind of cool because, we're doing all this policy execution. Okay, so storage and memory, again, the server is just storing these HMAX, so it's 256 bits. The policy lines of code are very trivial, and the client-side storage, again, is pretty minimal for these kinds. So we built this, and we integrated it into these, these tools. So like Joplin is open source, and we built like a trip planner using this custom GPT thing ChatGPT. So it kind of works for you. Okay, so I'll skip over that implementation, but going back to like how we started, what does the user see? And right now, we don't really have a story for what the user sees. They just see what you see right now. You could imagine the client developer supplying, like if you click the learn more button, they say, okay, yeah, we attenuate our request further, but we haven't implemented any of this and we haven't evaluated any of that. And these days, I guess, it would be not good if I did not mention LLMs in my talk. That's the thing to do. So my LLM contribution here is that you can throw the WASM at the ChatGPT and it will produce an explanation for what the WASM does. I don't know if that's actually going to work, but I had to say some LLM. Okay. So now, yeah, so part of this work is funded by folks like through a Google Faculty Award. And so what that gives you is like the ability to go and talk to actual people who are building the stuff there, okay? And so I went to the Google OAuth team and I did the Worship's presentation. And one of the big things was, client developer motivation, your part, right? Like, why do they care, right? And so they were like, yeah, some subset of developers are motivated. So these are like the big ones like Travis and Zoom and all these. But there are many other client developers who don't care, okay? And so then I told them, okay, but don't they want to reduce their risk, right? Don't they want to reduce their liability? And like, no, they don't care. Okay? So they just don't care. But what the folks there said that if the service provider has a requirement that a client developer has to use a mechanism such as this, then you can motivate the client developer to use this mechanism, right? Because it is coming as a requirement from the service provider. And the reasons for this are very interesting because like even if a client developer integrates with a Google service and the client developer gets hacked, the negative media attention is on Google. Oh, Google data stolen. So a large company is very motivated to kind of have these checks and balances imposed on a client developer. So that's one way. And what they have right now is that they require the developers to write an English justification of why they are accessing certain things or certain kinds of APIs. With our system, you don't have to rely on English, right? Now you have a WASM program that is basically representing your access. So that kind of analysis on the service provider's end becomes a lot more easier. Right now, they just have large teams of humans reading through these justifications. The other thing was that the client side state is very complex from an engineering standpoint. So they did not like this at all. Okay, so even though from a paper perspective, it's kind of cool that you can write a paper to do this and build a system to do this, but then when you want it in the real world, you're not going to bother with all this hashing and this client-side state management because you have to run a bunch of complex synchronization protocols that we had and that I didn't talk about, but just a nightmare from an engineering standpoint. So what is more likely to be used in production is a server-side design of the state. Okay. And finally, a fragment of this mechanism kind of exists. And I don't know if folks are familiar with like Zanzibar. It's like this low latency kind of scalable authorization system. There's a paper about it. And they built some custom logic to give a type of stateful auth type guarantee where you can only access Google Drive documents that you have created. So there's a fraction of this that exists, but it's like a very homegrown solution. So what we do is like we can solve it for any like client and server there. Okay, so I think I have like 5 minutes, right? Ish. So again, as I said, writing papers is one thing, but again, big focus in my research is to kind of see like when you try to take it to the real world, what happens, right? So the experience with Google, kind of talking with them about this work is one thing. The other thing is like with the startup that is using some of our work. And so the startup guys have this it's a cryptocurrency wallet startup. And they're like, this got nothing to do with cryptocurrency. But they're using like an integration with Google. And so Gmail has this very fine-grained set of mechanisms, right? So to the point here, Google could just have very, very fine-grained mechanisms to kind of select a very small subset of permissions. Right? And so what is being integrated here is like this thing called Ashby. Ashby is like a HR recruitment platform that needs access to Gmail. Okay. And so this system administrator at the startup, they weren't comfortable with what Ashby was asking for. And in this case, Google did have, pretty good fine-grained access. Now, what happens is that if the administrator turns off some permissions there, the whole thing just throws an error. So Ashby says, error 400 admin policy enforced. I'm not going to work until you give me all the permissions. Okay. And so then he goes and emails Ashby saying, okay, I don't, hopefully you can make it work with the privileges the app actually needs, not all this other stuff that does not need. So now this is a place where our framework can kind of come in to modulate this request so that Ashby does not throw an error, but still, it gets access to some subset of things. Okay, so I'm going to skip over this stuff here, but the point is that the work I've been talking about so far is for like 2 generic clients and servers on the internet. Now, if you have knowledge of how the cloud service runs, right? How the thing that is using the OAuth token, how it works, you can get a lot more stronger guarantees. You can analyze code, you can do a bunch of cryptography, you can do like trusted, you can do a lot of things. And like over the years, I've done a lot of work getting at stronger definitions of least privilege if you have domain knowledge of how the OAuth tokens are being used. If you don't have domain knowledge, then the stateful auth thing that I presented is one thing that you could use. Okay, so I will just quickly end here and talk about other things that we have been doing. And so one thing I'd like to do is that I have a bunch of side projects, and the side projects are almost always about hacking things. And science there is to explore new threat models. And these days it's kind of between cybersecurity and professional sports. And in the past it was a bunch of things, including like these don't stop signs that Gene mentioned. The other thing is adversarial machine learning, primarily because my students want to do adversarial machine learning. But I've been kind of on and off in this field for 10 years at this point. So the first thing is like, we wrote a paper where we hacked wireless gear shifters on bikes used in professional races like the Tour de France. And the idea is that an attacker can basically change the gears of a victim rider. And if they can change the gears, then you can cause them to lose time in the race. So this is an article that Andy Greenberg wrote after our paper was published. And the cool thing for us was that we worked with the manufacturer, like Shimano in this case, and they actually implemented our recommendations, and people actually raced a grand tour with stuff that kind of came as a result of what we did. So I thought that was pretty rewarding. The other thing is machine learning, these like so-called LLM agents, when the agent can interface with real data. So like ChatGPT can talk to your Gmail, whatever, that's where these adversarial examples become important. And so we have kind of optimization algorithms that can derive these gibberish prompts that mean nothing, hopefully, to humans here. But if you paste this inside something like ChatGPT or any chatbot window, what it's going to do is basically scan your history for PII, format that into a valid URL, throw that URL in Markdown syntax, and force the browser to execute a load that will exfiltrate that PII from that window. Okay, so this is kind of like a adversarial example for agents. And we kind of showed this for like a company called Mistral. They're like one of the big players in the space, and they actually kind of fixed their system by basically disabling all of that. Okay. So the thing I want to highlight here is, again, like we want to, you write papers, but also it is important to kind of see how it interacts with the real world. Right? You want some kind of change in the real world. Okay, so I will end right there. So the takeaway is that you're not going to get like least privilege in like the absolute sense of the word. You're going to get some version of it that is kind of tailored to your use case. But you're going to have to kind of navigate these trade-offs. And I try to kind of bring up some of these trade-offs that you have to navigate. And so you can solve the problem generically for something like OR. And we showed you one way of doing it using this abstraction of a client-supplied reference monitor and statefulness. And if you have knowledge of how the platform works, you can do a lot more. So yeah, that's all I had, and thank you for the great question.
Ended right on time, but if anyone has questions, maybe if you jump in.
So, this whole talk makes me think about, permissions and least privilege. Can you hear me?
Yes, yes.
In Java and C#. So Java had the security manager, which had like a permission model, a bunch of permission checks. They expect the client to provide maybe even quite potentially fine-grained permission checks, and it ended up being so complex and such a performance overhead, which I think you talked about in terms of synchronization with with your own solution, that eventually they just decided it's not worth it. We're just going to deprecate the whole thing. C# did the same kind of thing for their kind of permission manager. I'm curious to what extent you feel this may or may not, or something along these lines, may not end up in that place where it's like, oh, the performance to check all of this is too expensive, and
Right.
I can't put enough maintainers on this. Forget it. Let it be someone else's problem.
So, yeah, so I mean, the complexity here is kind of pushed onto the client developer. The only complexity on the server is like maintaining an execution infrastructure for WASM. And that can be done that is being done at scale at like Cloudflare and all these places. So like from an engineering standpoint, that seems to have been like more or less like addressed, I think. Like, so there's no complexity on the authorization server side of things. Of course, like when you go and try to actually implement this in the context of an OAuth server, things might come up. But the idea of like running WASM in the cloud and running untrusted code inside the WASM at that large scale, people seem to be okay with that. The policies that we showed were like fairly simple. Like there could be additional complexity in the policy that comes up. Like we weren't able to think of more complicated policies than the ones that I showed you. So maybe it could remain simple there, but I don't know. It could become also pretty bad. Not sure exactly.
Anything else? Like once, twice, done. Thank you again. Are you all waiting for some magic word, right? You got a word for that? Wait a minute. That's why nobody was leaving.
I think it's just Fernandes.
It's still there. It's a privilege. Now it's still there. Are you spelling it? He's a privilege with privileges. How did you know? You just did it. My notes, I can just spell it.
Well, looks privileged.
I'm sure there are other. Nothing happened to put the same equivalent.
We're not like that again.
Record in that database.
Sounds just.
Meaning, right, and you don't modify once it's there, you don't modify. It gets stored. So, read once. Yeah. Right, we would want to know that some trip-related email was modified. And set to zero, like, you know what I mean?
Would that be doable?
Resetting the corner.
Doesn't sound obvious, right?
You could do this. Yeah, yeah,
But
yeah.
but what you have to avoid is that state explosion, right?
Yeah, yeah, so. They said that the council of proved that there was a right to the.
Ah, right.
And the server knows that, and the server is governing, like, was there a
That's
right?
right,
to just
that's
write it
right.
down? So you could write this. It could be very convoluted. It could be I just write it.
Well, for example, I'll give you maybe a more accurate example. You suppose you mail a things trip X. That email was appears at some point in your database, and then you have another email that pertains to trip X, but supersede the previous email. You know what I mean? Trip is modified. So you now want to make sure that the program does not pass. Yeah, if you very much I mean, one supersedes the other, so you want only access to that.
There's the second email, right?
Yesterday,
Same sender.
Yes, but the supersede. Let's say your trip has not looked at any of them, but you want to make sure.
Chen was the second.
Now, this privilege dictates this should. But you see, but in ideal world, it should be done, right?
Exactly. There is an abstract least privilege.
Right, and I think that's your nirvana, that's your nirvana. Right, you're gonna post, but you can't quiet me.
We have a right.
So there's like two things, right? There's,
People will actually choose to solve the problem.
some code.
Love something with
that-
I enjoyed the question.
You're changing tips and trees to be.
Only one less thing to worry about.
Inform me and I can bomb this.
That is possible with your expanding. I hope I got to your hacking.
Yeah. Okay.
You don't have to implement it.
There's a million questions here, always,
Yes.
these things all.
Figure out the right
So we're just
design
comparing.
of this, that would be.
Yeah, I'm not sure how physiological.
So many people. The state of the world is going around.
Honestly, the counter if you're trying to calculate.
No, I like that part, I like that part.
You're already in this room, you know, so.
Yeah, they have.
You know what?
Think
Think about the machines, so you
But
talked
they were
about
like
that,
the
you said it
OAuth
should be
team, so
easy.
this is like.
Well, I can also, it's a little bit, remember.
All right. So let's go to deposit stuff.
So, you're still got room for me?
Yeah.
Professor B is out,
Okay, good. Good, good.
but I don't have a car, so somebody.
Okay,
will have to-
does it, you have a car?
It's not
You have,
far,
right?
it's just across
Okay,
the bridge.
because, I can take two, I can take three people, but I can't take four. Okay, so maybe you can go together. I'm sorry?
Did you buy a big Tesla?
I don't like Teslas. I don't buy anything from
I saw
Elon. That was my oldest daughter.
Oh.
That has it. I can only influence people so much.
You got a Tesla, right?
Oh, you're working with Mike, Mike published, didn't Mike?
That's what it is.
Yes.
This is like related to EV type
Oh,
situation.
Charlotte,
Yeah,
I'm gonna see you as soon as I can get to your decade event.
I guess we're coming, right?
Yeah.
You're showing up, right?
Okay, so, why don't we just, so you go with, Aviva, and we meet at, Fellows.
Oh, this is like social network, got it. So are you working in like data structures?
It's sort of like. Randomly generated.
Oh, that's very interesting. Oh, that's like, that's a very rich, right?
We're studying like problem lists.
Like that's mathematically rich.
Yeah.
Okay.
Format.
So you worked in cryptography though?
When I was in undergrad, I did a little bit of cryptography. But I've moved to more computational science.
Okay, gotcha.
As of right now, this will.
I mean, like, to be fair, like, aren't there like 3 professors dedicated to computational geometry at
There are two, and then.
There's
Schindler-
Epstein,
oh,
Goodrich,
maybe
and
Doancourt?
yeah, Doancourt. Yeah,
I'm not sure what.
okay. He's very old, right? Yeah. The younger professors are
Schindler,
Schindler. Yeah, I guess is he a theory guy?
he is, oh, he used to be CS education, now he's moving,
Oh, he's moving into actual theory now.
he's, definitely, smart guy.
Oh no, I'm not doubting that. I'm just yeah, but there's
He is doing, I think he's taking students, but they might be CS educators.
and then there's Giannis.
There's Giannis, there's Vijay,
He's not good.
oh yeah, he's nice. There's Giannis,
Yeah, that's another thing. It's like markets, algorithm, game theory, that sort of thing, and there's computational geometry, and that's the main two areas, right? And then there's a
Sandy
Sandy
does,
is yeah,
her
but
own thing.
she's kind of like in her own.
Yeah. No, Kurosh is also.
Ratio. That's it, right?
There's Stanislav Cherokee.
Yeah, but he's not. That's not. That's theory, but only kind of.
Well, it is,
Well, it's theoretical, but it's not theory. There's a difference. I think there's a distinction between the two.
I don't know, not very knowledgeable about that distinction, but I know or theory.
Okay, maybe it is. Yeah. It is. I guess security is
Security is
very
but
different.
yeah.
Well, because like there's a lot of like for example, there's a lot of theory in like ML, but that doesn't mean we consider it theory.
Yeah.
I guess that's because it's statistical.
If you've been following along in class, there's a lot of like.
Oh, yeah,
complex
yeah,
theory,
yeah.
reduction
I
stuff that
Well, and not just that. There's also like it's not like a
number theory. And,
well, no. It's like between complexity and cryptography. It's not like a one-way street. It's like a two-way street. Like there's stuff from cryptography that goes to complexity.
Yeah.
Like like for the P versus NP thing, like yeah, there was like a certain like paths, right, that people were thinking about towards how to prove, right?
Sure.
And like cryptography is the reason why like
It's
some
a powerful motivator for sure, because if P is equal to NP, then a lot of.
well yeah that the point is that like there was one approach they were considering and then someone proved a result such that like if that was true then like all of cryptography would be falsified and then people just I think they were like well it's unlikely that's the case.
Yeah.
So they kind of moved away from that approach. But anyway, yeah. No, I get what you're saying though. Yeah. That's cool, man.
Anyway. What have you got? We can be in my lab if you. Okay. If you got it before.
Sure. And then yeah, tomorrow we can set it
We'll
later.
meet tomorrow. I can make myself available. Not at too much in the evening. I'm busy at 8 p.m. But
Tomorrow at 8 p.m.
I mean, I'm busy tomorrow at 8 p.m. But
Yeah, we can
sometime
meet
in the
before.
afternoon.
Yeah, that's fine.
Thanks.
Swear to God, they're pretty crazy again like last week.
Are you here from the speaker session earlier?
Yeah.
Cause I have to clean up the rug and put away chairs and stuff.
Oh, sorry.
Sorry, I didn't know if you were like in here waiting for something else.
No, I, yes, yeah.
Alright,
No worries. How are you doing?
yep, you too. They need me to end the meeting. Oh, ugh.